Let's use side-side angle to solve a problem. Here's a picture of what side-side angle looks like. Notice the angle is not between the two sides we know. Suppose we want to find all the angles. Start with this one. Set up the law of sines. Remember, have your angles and your sides oppose each other. Cross multiply, and now isolate sine. I'll divide by 6 to do that. The thing on the left is something our calculator can do. And now to isolate the x, we'll use inverse sine, which our calculator can also do. Inverse sine is unique among the inverse functions in that when you get an answer from inverse sine, you're not necessarily done. You have to also consider what's called the supplement, or 180 minus whatever your calculator gives you. I worked that out here. We'll call this the supplementary rule for inverse sine. Inverse sine leads to two different possible answers for the angle x. And now that we know what are two possibilities for x, let's take a brief moment to consider how a triangle could have two different answers for an angle. In reality, it's because if we were to draw these properly to scale, with the 10, the 6, and the 30 as given, we would physically see that there are two possible triangles that can have these conditions met. This is not something that you as a student would ever have to draw. I use technology to draw these properly. But it's worth taking a moment just to look and see that there really are physically two triangles that could meet the original constraints. We'll put that aside as that's something that you as a student won't necessarily do. But now that we know there are two possible answers for x, let's consider two separate triangles, one where x is 56 and one where it's 124. Since our goal was to find all the angles, the only thing left to do is find the remaining missing angle. But that's easy to do using the 180 rule. Using the 180 rule, I was able to figure out the third angle in each triangle, and therefore I've solved this problem. Thank you for watching.